So we're looking at this question for physics. So the question is saying uh, simple machines are used to make work easier in our daily lives. Then they're saying define a simple machine. So a simple machine, it is a device that makes work easier. That is a simple machine. So B is saying figure 3.1 shows a man hauling a crate of tomatoes of mass 2 kg onto the trunk using what? A rope. Okay, so you can see that man here putting a 20 kg crate of tomatoes. Okay, and the length of the plank is 5 meters, and the height at which it is going, it is 2 meters from the ground. Okay, so the question is saying calculate the velocity ratio of the system. Calculate the velocity ratio of the what? System. So we calculate now, we'll say that, okay, so we'll move that velocity ratio is equal to dE over dL, meaning the distance moved by the effort, distance moved by the what? The load. So velocity ratio is equal to the distance moved by the effort is this one here, the one the person is using to pull. So this is the effort here. So what is the distance? Is 5 meters. So say 5 meters divided by, we come out to the distance moved by the load, which is this one here, so which is going to be what? 2 meters. So meter and meter will be cancelled, so our velocity ratio is going to be, so our velocity ratio is going to be 2.5, no units, because we have cancelled the meters there. Okay, so now we are told to calculate mechanical advantage if the man pulls the rope with a force of 150 Newton to raise the crate on the trunk. Okay, so we know that mechanical advantage is equal to load over effort. So if you are not sure, if you always forget about this formula, just write the word what? Male. If you write the word male, it will be telling you to say L is load, then E is effort. Now, let's analyze the data. What do we have? Let's analyze the data. So if we analyze the data, we'll find that effort we have, which is the force, which is 150 Newton. Then mechanical advantage, we don't have, it's question mark. Load, we don't have, but we can find, because we know that load is equal to weight, and weight is equal to mass times gravity. Okay, so therefore to find our load, we are going to say that our load is equal to the mass, which is 20 kg for the crate of tomatoes, times the gravity on earth is 10, so our load is going to be 200 Newton. So therefore we'll say that, okay, our load now becomes to be that is 2000 Newton divided by the effort is 150 Newton. So Newton and Newton will go, and when we divide that, it's going to give us 1.3. That is our mechanical advantage. So we'll write there 1.3. That is our mechanical advantage. So now we calculate for efficiency. So we know that efficiency, there is a formula which we say eta is equal to mechanical advantage over velocity ratio times 100. Okay, so this symbol like this one here, it is called eta. It is called eta. It's a symbol for efficiency. So much like it's N, but you protrude it going downward. So from our information, we're going to say that eta is equal to, what is our mechanical advantage? It is 1.3. divided by, our velocity ratio is 2.5 multiplied by 100. So finally, eta is equal to 52%. So you come in write 52% as our efficiency. Then we have the last question here, which is the babyest. The question is saying, explain why the simple machine in figure 3.1 is not 100% efficiency. Because there is loss of energy due to what? Friction. Because there is loss of energy due to what? Friction. So that was the question 7 on simple machines. So we'll meet next time in the next video about simple machines. Otherwise, thank you for your time.